and welcome to the Daily Space Weather. Man, if you saw yesterday's video, you might have seen some spectacular image coming at you from the Smash News Network least busted name of news. Today, it's even more spectacular. First thing we're showing you here is the last 24 hours of SDO 171 angstroms. And you may see a bunch of activity rising in the east. You may see a bunch of activity setting in the west, especially in the southwest. That is where the real action has been happening. And how about a little closer view of that southwestern limb? So there was a huge filament eruption, also 2 M-class flares. We'll tell you all about it on today's Daily Space Weather. What's that? You want to see that even closer? Smash staff, can we accommodate them? Okay. There is an extreme close-up of a huge prominentiary plasma reorientation. Did it lead to a coronal mass ejection? Well, not really. If there was any ejected from that, it's barely to invisible on the coronagraphs. Once again today, we did see an M-class flare erupt, as we did show prep. Here's 304 plus 335 angstroms. We'll subtract the 335 for some additional early video money shots for you. There's ionized helium by itself the past 24 hours at SDO. And we've got like 3 new named sunspot groups, by the way, in the Northeast. Or three new sunspot groups that haven't been named yet that will get names. So you can expect to see the sunspot number rise once again today, perhaps even the radio flux. It all depends on sunspot growth. Huge filament down there in the southeast. This long feature you see right here is the sort of thing that can turn into what we call solar storms. Here's that southwestern limb once again. Huge plasma filaments there stretching across the solar equator. And magnetic fields there arching plasma up hundreds of thousands of kilometers up into space, defying gravity. Man, that is some good stuff. Here is the extreme close-up. I suspect we didn't disappoint with these videos. Yowzers. A great example here of a prominence that was not associated with any coronal mass ejections that we can see. If we're incorrect, let us know in the comments. That is a good one. Anyway, let's take a look at what's been going on yesterday plus today in terms of sunspots. Here is your SDO continuum. And so growth continues in this group up here. Growth continues in this group down here. A new group just appeared right here. So we may have as many as 4 new named sunspot groups today. As many as 3 up here in the northeast. This one down here got a name. This one here is going to get a name. That one right there. And yeah, so it's a continued uptick here in solar activity. We'll even give you some rational theories as to why and how you can follow it yourselves. Yeah, some rational, plausible explanations of the sun's mechanisms, the mechanisms that drive solar activity. This is colorized magnetogram yesterday plus today. And if you enjoy the channel, here's a quick tidbit as to how to support the channel. First of all, you can support us by becoming a member of the Smash Team at smashomash.com/Smash Team. We needed superior capabilities to Patreon. Patreon didn't have all the stuff that we offer on our own website, so we built our own. The operation is Smash staff and me. That's it. And there's a gold level, there's a silver level, there's a bronze level, there's even a gold annual paid-up subscription that includes complimentary merch. That's the best value, smashomash.com/Smash Team. If you want additional content, some of which has nothing to do with space weather, smashomash.com/Smash Team. You can also support the channel via our affiliate/sponsor links. You'll find those below the video in the description. Don't forget to enter the promo code SMASHOMASH when you're shopping at Hemp Lucid. Yeah, hemplucid.com. Enter the promo code SMASHOMASH to save 10% on your checkout for your great CBDs, Delta 8s, mushroom gummies, immune stacks, body balms, pet CBDs, and lots more. Again, you'll find links below this video in the description. Enter the promo code SMASHOMASH to save 10% on your checkout. Thanks to everybody who's been picking up products, and thanks to Hemp Lucid. We've also got custom merch. Today's featured product is 20% off like everything else at the Redbubble shop. Today's featured product is Mensa, which stands for Make Earth Not Suck Again. Why? Well, because the best way to get out of a hole is to stop digging. We also have a Mansa product, which is Make America Not Suck Again. Some of you may have noticed that the planet has sucked for the past about 3 years. Let's take a moment to give a slow clap to bureaucrats who are unable to get out of their own way or do their own jobs. Thanks, bureaucrats. You're really qualified to make my health decisions. Now, our regular viewers may be aware that I became a pro mountain biker in 1999. I don't rely on people like Rachel Levine to provide my health decisions, although Pennsylvania would have liked it that way back in 2020. Anyway, this is actually our third bestseller. Even now, there are even Mensa products in Tasmania. Yeah, Tasmania. Anyway, it's up to you to make Earth not suck again, so do your part. We also included our .org site, which will redirect you to smashomash.com, because we are in the process of doing all kinds of things like building an observatory, and we need help from people like you. There's also an Amazon shop. Today's featured product is in our cycling collection. It's the Springfield Indoor-Outdoor Big Bold Thermometer. Excuse me. The dangers of filming live. Anyway, Springfield Indoor-Outdoor Thermometer. It's only $7.99. You can find lots of other products that may strike your fancy there in our cycling collection, our Amazon store. It's amazon.com/shop/smashomash. We are paid commissions on that. Keep in mind, that is why we are able to endorse some products. Smashomash.com contains all of these links. If you're unable and or unwilling to open your cobweb-encrusted wallet, help us out with clicks, press the share button, view our shorts, etc. Leave a comment. Thanks to everybody who has supported the channel in the various ways, whether it's just simply viewing the videos or whether it's getting involved in getting extra content and increasing the probability these videos will continue to exist, remain publicly visible, and free for all to view. Let's get to volcanoes. There's a picture of Suminose-jima from satellite for some reason. I don't know why. It's just showing a bunch of clouds. I don't really see anything there. Suminose-jima did explode. No indication on the size of the ash plume. Popocatépetl also exploding in central Mexico, flight level 210. It's a 21,000-foot plume of volcanic ash from Popocatépetl. Sangre exploding in Ecuador, flight level 200. Cotopaxi in that same nation, flight level 200. Those are 20,000-foot ash plumes over the South American nation of Ecuador. And last but not least, Sabancaya in Peru, also exploding, flight level 240. Don't pole vault the caldera. Next, global seismicity. The largest quake of the past 24 was a 5.8. We'll get to it. We'll cite the quakes that are above a 5 magnitude. Here is your USGS map. The first 5+ magnitude quake was at Vanuatu. That was at 1909 yesterday evening. 1909, a 5.0 struck Vanuatu. It was at extreme depth, over 600 kilometers estimated depth. If that happened at the surface, that would be like a 6.5 magnitude quake. There was also a 5.7 southwest of Africa there, near the African/Antarctican plate boundary. And then at 0 dark 52 this morning, there was a 5.8 at the Volcano Islands there, south of Japan and east of Taiwan. Besides that, no quakes over a 5 magnitude. And how about if we get back to space? Space, a frontier. We're advancing the field of cosmology by creating these videos. I almost went to school for cosmology when I decided to drop out. I saw the writing on the walls back in the mid-1990s. There really wasn't a major offered for cosmology back then. Man, check out the image. That is fantastic. That's 211 plus 171 angstroms SDO. There's the full disk view. Splentacular detail there. Great depth shown in the solar corona, and you can see some coronal holes, which we will get to here in a moment. Let's talk about some space stats. Yeah, space stats. The 10.7 centimeter radio flux is pretty important. Did you know it's directly proportional to sunspot number? Meaning when the radio flux goes up, so does the sunspot number, and vice versa. It's currently at 154 solar flux units, which is right at a breakout point, because you may see a lot of ups and downs right around the mid-150s. Do you think the sun's going to break out and get above 234 solar flux units in this most recent solar uptick? Let us know in the comments what you think. Space Weather Enthusiast Dashboard isn't forecasting any sort of geomagnetic storms or geomagnetic unrest conditions. NOAA's forecast includes a heap and help and a nothing. So it is clear sailing out there. We will take a look to see if there are any additional coronal mass ejections headed our way. And thanks for leaving a comment, Mr. Katowski. Here's Earth's magnetic moment from space for the past 4 hours. And we've got a diffuse and kind of slow solar wind, so there is not a lot of magnetohydrodynamic pressure out there, which is what's being depicted in these geospace magnetosphere movies. And if we didn't have so much solar imagery to show you today, we'd do a cosmic ray report. We'll have to do that tomorrow, so make sure you tune in to tomorrow's daily space weather video. That's the last 4 hours of Earth's magnetic moment to about 12 Earth diameters in space. Here's Earth's magnetic moment from the ground. The Geospace Ground Magnetic Perturbations Map is a great map to consult if you think the aurora might be visible in your area, or if you're worried about your power grid going down. You'll be able to get a good indication of where the likely induction, telluric currents, etc. are happening. At the moment, the last 4 hours have been quite calm. The last 4 days have been quite calm indeed. So here is our planetary K-index, a general average of global geomagnetism. It's KP 1.67. KP 1.67, geomagnetically calm conditions. Next, looking at the real-time solar wind, and this is pretty calm also. Solar wind density here, as reported by the ACE spacecraft, is about 2.3 protons per cubic centimeter. Solar wind, let me repeat that. Solar wind density is about, well, make it 1.5 protons per cubic centimeter. Solar wind speed, 375 kilometers per second. Goes magnetometers here, just in a normal operating range. Nothing too remarkable happening there. But the next frame, kind of important. So this one is depicting the top view ecliptic plane. It shows you the heliospheric current sheet and its polarity. Earth has recently moved into a North Pole current sheet, depicted here in green. But the real important feature is, let's bring up the last image, is this. That is a North Pole-oriented coronal hole still hanging out at the North Heliographic Pole. And it's going to suddenly snap down. We're going to see that coronal hole migrate across the equator to the southern hemisphere. When it does, you can expect a big uptick in solar activity. If you didn't hear it anyplace else, you heard it here first. You're welcome from the Smash News Network, least busted name in news. Anyway, next is our line of sight field plot. Here the sun's B field is depicted in blue. That's the field that goes through the magnet. The polar fields are green for north, red for south. It also shows the gong magnetogram there, and you can see a lot of magnetically organized regions on the Earth-facing portion of the solar disk, which brings us to our line-of-sight coronal hole plot. And we're starting to see that north heliographic pole coronal hole come through. You can see it up here. It has been there for the entire solar cycle 25 so far, and when it suddenly moves, and it will lurch to the south, that is the uptick that we have been calling for. It's coming. It's coming. And here are coronal holes from SDO. That's another 24-hour custom HelioViewer video for you. Some quite well-defined coronal holes there rotating in. These are of North Pole orientation. Again, this one up here is the most important feature as solar cycle 25 progresses. Sunspots are important. Coronal holes are important. Polar coronal holes are the most important. And let's move to sunspots. So first, our integrated space weather analysis center page showing the solar flare probability, which is very, very high. We've got a series of large sunspot groups setting in the west, and there are some in the east as well. So our regular viewers may be aware that large solar flares appear more likely around the limb as opposed to the center of the solar disk. And just to reiterate, there are like 3 new sunspot groups that should get names in the northeast. So if anybody's on YouTube telling you that the sun is shutting down, they are more out of gas than a Tesla plugged into a solar panel to charge over the next 18,000 years. Before we get to energetic particles like the ghost proton flux, let's take a look at sunspots in stunning detail from SDO. There is the equatorial zoom. So we're going to have one new named group here. This group that just formed right there, that is a new sunspot group. There's a group here that'll get a name. This group will get a name. And I think there's actually one up here as well. We'll show you high-res imagery of that momentarily, a little bit later in the video. And let's talk about energetic particles. We ain't got none. The ghost proton flux is flatlined. No SEPs, solar energetic particle events. The X-ray flux features 2 M-class flares in the past 24 hours. The larger one was the more recent, I believe. That was an M1.37. The earlier one was an M1.24. So let's take a look at our favorite flare wavelengths. Keep in mind these are not raw X-rays. This is still extreme ultraviolet light. It's just that 131 plus 94 angstroms take more images per minute than the other wavelengths. They are specifically formulated to view solar flares. It looks like both of those flares came from the southwest, which is, again, indeed where the action is. How about an even closer view? Good times here at the Smash News Network, least busted name of news. We're delighted to bring you imagery of this level of quality. So let's take a moment to reflect on what's going on above our heads. If you want to find out what's going on above your head, head to skyandtelescope.org. You can make a star chart that looks just like mine. This is what's going on overhead over Allentown, Pennsylvania. We are located in Lehigh Valley. That's about as specific as I'll get, as my location is classified. I wonder what time sunset's coming. The sun sets around 8 o'clock tonight. Around 8 o'clock. And if you are up around sunset, you may see Venus, Mars, and the moon up there. Also Regulus, a bright star there, is right on the ecliptic. Next, your solar system forecast. This is where heavenly bodies are today. Let's advance this 1 week. Please leave us a comment if you're viewing this video from someplace besides Earth, like a spaceship, alternate plane of existence, alternate multiverse, universe, planet, asteroid, comet. Let us know if you're an actual star watching the videos. Maybe you're a galactic core who's been tuning in. Make sure you leave us a comment. Tell us all about it. That's where things will be on June 6th. Continuing on to look at coronagraphs. These are the CMEs from yesterday. That's 102 frames. And indeed, there are some CMEs there. They do not appear to have any earthly directed components based on the imagery that we have. Pardon the excessive disclaimers. Here are today's frames, an additional 27 frames there. Nothing too exciting happening there. The most recent M-class flare or two, one of those did seem, I think the most recent one actually did generate a CME. So that is still in the process of propagating here out of the southwestern limb. We don't anticipate it to be earthly directed, as it is quite far from center disk. Although we will have to just wait and see what happens there. Those are the Soho-Lasco coronagraphs. And let's take a look at also stereo A. There's the stereo A diagram just showing you stereo A and B. Also, it shows the Parker Solar Probe, Bepi Colombo, etc. You can visit it yourself if you want to follow that. It's the Where is Stereo Today site. And here is stereo A on the left and Soho-Lasco C3 on the right. So just minor CME activity here, and keep in mind that if you don't look, you won't see it. So you can't make assumptions with this kind of stuff, folks. You have to just look at the data. And by the way, if you think you're quantum entangled with things that you can't measure or that you don't measure, you are not doing science. Everything is not connected, folks. Some things are connected. If you can't measure a thing, you cannot prove that you are quantum entangled with it, which means it is not science. It's conjecture. Or you could say it's dogma, or you could say it's crap, or you could say it's nonsense, whatever you prefer. Anyway, it's not time to enter your bunker, because space weather isn't particularly dangerous about 1 billion times out of 999,999,999 times. Although 1 out of 1 billion times, it can be quite dangerous. These are all 24-hour videos featuring 193 angstroms SDO, the Soho-Lasco C2 and C3. And let's drop those coronagraphs and just show the SDO. All right, so let's shift gears here before we get to our bonus features segment and talk about filaments, because filaments are pretty serious. Again, they are the source of coronal mass ejections oftentimes. So let's take a look at what's going on with filaments from the ground-based El Teide, Spain Hydrogen Alpha Telescope. And again, we still do see some massive filaments on the earthly facing portion of the solar disk. namely this one down here. I mean, this one could really use a name, by the way. And if you like to name filaments, follow the hashtag #NameThatFilament. Name it after a living person, maybe your favorite friend or foe. And do it over on Twitter. You can find links below the video to our Twitter account. It's at SmashOmash. We're all over the internet at SmashOmash. Hashtag #NameThatFilament. This one down here needs a name for sure. So join us over there. Additional content on the Twitter feed as well. I don't know if it's controversial enough, but let us know what you think in the comments. Now, the Go 16 SUVi has been down. I'm going to press refresh just so you can see that it will not refresh. At least it would not refresh. So it's just sitting there loading. So that's kind of a shame, but hopefully that will be back online soon. And let's take a look at some filaments without looking at the Go 16 SUVi. So here's our 193 angstroms wavelength. We've added 304 angstroms to add some additional contrast there for those filaments. Again, this filament right here could use a name. So perhaps name it after your... Please don't name it after a politician. Seriously, name it after whoever you want. Hashtag #NameThatFilament on Twitter. We will consider doing so. Occasionally I just give up on people and I just name it myself. Although don't worry folks, the Smash News Network, least busted name in news, doesn't really give up on you. Let's go to our bonus features segment, starting with our Satellites Community Dashboard to check charging hazards, which we don't see any of. Charging hazards are clear. The GOES electron flux here is in a nominal range, kind of right in the middle. Nothing exceptional or remarkable to report on there. There is the 1-year graph of the greater than 2 mega electron volt electron fluence. Here's the forecast model. NOAA, they're forecasting a little bit higher levels than what we saw. Expecting a dip here in the electron flux. No argument from me there. That's the forecast model from NOAA for the relativistic electrons. Since those are measured at the F layer of the ionosphere, we'll show that as well. Feel free to pause the video on this frame if you're not familiar with distances in kilometers, chemical concentrations, electromagnetic radiation penetration, etc. Here is the vibrational frequency of the bridge between Earth and space. The F layer of the ionosphere, the upper thermosphere, the thermosphere, the layer of the atmosphere that gets hotter and hotter as it gets more and more diffuse and merges with space. Welcome to space. You're in it. If you think it's fake, please press the unsubscribe button. Here is the anomaly in megahertz from a 30-day median of the ionosphere. Once again, like yesterday, we're seeing quite a bit of low-frequency anomaly here in the southern hemisphere. And here's the latest image. That's 1145 universal time ionogram and 1145 universal time anomalygram. Total electron content depicts free electrons up to about 12,500 miles of altitude. That's about where your GPS satellite is located. Feel free to pause the video on this frame if you're not familiar with distances in miles to these higher objects. Here's a total electron content forecast. It'll show you the most likely places to see GPS errors. We are indeed seeing some nighttime GPS errors around the equator, especially in the northern hemisphere. Also some quite far south GPS errors there in the southern hemisphere. That's the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. The free electrons to about 12,500 miles of altitude. Here's just North America's 10-day anomaly. That's the total electron content anomaly from the 10-day average. No major anomalies showing up there on the North America map. Next, the latest intensity gram and the latest colorized magnetogram. So first of all, these groups up here, you can see there's a sunspot there, there's a sunspot there, and this sunspot down here. That might be 1 or 2 sunspot groups. Doesn't really matter to me very much. I'm not worried about counting sunspots. Also this group right here. So we're expecting to see at least 4 new named sunspot groups today. And if you think the sun is shutting down, I don't know what you're looking at, but you're not looking at reality. Let's get to our meteorology segment. Because here at the Smash News Network, these busted name and news, we believe in value-added services. So here is the windiest place in the world. It's featuring like 70-mile-per-hour winds at the very least. And it's quite close to Taiwan there. And yeah, that's our nullschool.net wind map. We have zoomed in on that typhoon. It has weakened a little bit since yesterday. It is still producing some 30-foot seas, way down from 50-foot seas that we saw a couple of days ago. Oh, I'm seeing some 35.5-foot waves there. That's nothing to sneeze at, whatever that means. I don't know why you would sneeze at a wave, but anyway, that's probably the waviest place in the world as well. The Southern Ocean is just not stacking up. So wave chasers, it looks like a good day to surf Taiwan and the northern Philippines. Anyway, these are the surface winds of the eastern world. Shout out to our viewers from all around the planet. We are frankly surprised that with the pathetic and disgusting censorship on basically all social media platforms, we're surprised that you've been able to find the content. Social media, it's about as social as locking yourself in the basement with a bottle of whiskey for a week. Next, jet streams of the West. Incoherent jet streams still dominating the U.S. here. A huge divergence happening here over the southern Rockies. And again, incoherent jets here. We've got a large upper-level anticyclone here right around Lake Huron. You can see that clockwise rotation. The telltale sign of high-pressure zones in the northern hemisphere. Incoherent jets over the U.S. is the story for the United States. You may see some weird weather patterns as a result. It is not HARP. It is not chemtrails. It is not cloud seeding. It is not weather modification. It's the jet stream. Stop believing nonsense on the internet. Contrails are not geoengineering, folks. They are pollution. They do make the planet cooler in the daytime, and they do make the planet warmer at nighttime. However, they are not geoengineering. Next, the central world's surface winds, shown here and here, are Europe, Africa, and Central Asia's jet streams. Continuing right along. And here we've got our windy.com map, showing some waves there, showing some waves. And let's just show global pressure. Yeah, we're just going to show global pressure. That sounds like a good plan, right? There's the pressure map. I imagine that's probably the world's lowest pressure. Let's briefly zoom out here. Of course, the Southern Ocean, as winter approaches, will definitely feature some quite low pressures indeed. Anyway, there's your full planet pressure map from windy.com. They got a great mobile app. Perhaps check that out. And next, we've got clouds and fog over the Americas. That is shortwave radiation, part of the infrared spectrum. It shows clouds and fog at nighttime. You can use it to get an idea whether or not you'll be able to see the aurora next time it comes. And it's coming. Did you know you're about to enter the 6 brightest weeks of the year, or the 6 darkest weeks of the year? We'll talk about that momentarily. You know, the 3 weeks preceding the solstice and after the solstice, those are the sunniest 6 weeks of the year, and the darkest 6 weeks of the year for the southern hemisphere. The 3 weeks before and after the solstice. Anyway, here's your weather.gov map, and that is what's going on for weather alerts. We've scrolled down to show you the key. That's about all we can do here. If your location is lit up, head to weather.gov and click it. Those are something like frost advisories there in parts of Maine and New Hampshire. Here are some weather forecasts since we're seeing some temperature anomalies showing up. That is your temperature anomaly forecast based on a GFS model in degrees Celsius. 72-hour GFS temperature anomaly forecast in degrees Celsius. We'll also show pressure and precipitation. That is the same model, the 72-hour GFS model. And next, let's take a look at lightning. There was some extreme lightning in the Gulf of Mexico over the past about 10 hours. Also off the coast of North Carolina and Virginia, some heavy lightning there. And some significant lightning in the center of the country, which has since subsided. Let's see if we have any current terrestrial strikes. And it looks like a minor thunder shower up here in Minnesota. Anyway, there's the full global view. Like yesterday, a ton of lightning there north of the Mediterranean. Here's your U.S. Doppler radar map. It shows vertical motion in the air column. We'll focus on the lower 48 now that we've showed you all 50 states. There is clouds and fog. Rapid cloud nucleation happening there in the Gulf of Mexico once again. Some huge pressure gradients forming there as dry, cooler, massive air causes some rapid convection. Huge pressure gradients happening right there. And again, you can see these incoherent weather patterns here. You can see the jet stream kind of curling around here and blowing east to west. You can see some collisions happening in this area. The western Great Lakes. Anyway, we're going to close this thing out. This is the recap. Doppler radar for the lower 48. Clouds and fog. 3.9 micrometer infrared radiation. Clouds and fog when it's too dark over half the country to use the visible satellite. And there's the water vapor map. It doesn't just show moisture. It also shows dry air. West Texas, looking like it likely has clear skies. So anyway, thanks for tuning into the Smash News Network, Least Busted Name and News. Don't forget to leave a comment, press like, share, etc. We'll see you soon. And in the meantime, may that solar wind be at your back. I'm headed back to the bunker. Yeah!